Hello everyone, I am Muskan from BSc Chemistry Honors first year. My roll number is 21. Today I am giving presentation of inorganic chemistry assignment. So the first question is, what is diagonal relationship? Diagonal relationship in the periodic table refers to similarities in properties between certain pair of elements diagonally positioned in the second and third period. The diagonal relationship is a phenomena where elements diagonally positioned in the periodic table exhibit similar properties despite belonging to different properties. This similarity arises due to interplay of factors like atomic size, electronegativity, and polarizing power, which change in opposite direction as you move across a period and down a group. What are interhalogen compounds? Interhalogen compounds are formed by reaction of two different halogens like ICl, BrF3, and their properties are that they are covalent and diamagnetic, more reactive than diatomic halogen bonds. Physical property intermediate between the two halogens involved. The bond length depend on size of constituent halogens. Exist in gas, solid or liquid state. What is inert pair effect? Inert pair effect, primarily observed in heavier p block elements, refers to tendency of outermost s electron to remain non-bonding or inert, leading to preference for lower oxidation state than expected. The inert pair effect describes the reluctance of s electron in outermost shell of heavy p block elements to participate in chemical bonding. This reluctance is attributed to poor shielding of these electrons by inner d and f orbitals, causing them to be held more tightly by nucleus. The effect is more pronounced in heavier elements of group 13 to 16. Consequences: lower oxidation state results due to inert pair effect. The stability of a lower oxidation state in these element increases. Fullerenes. C60 fuel. So fullerenes are made by heating of graphite, and electric are in the presence such as inert gas, helium or argon. The Scotty material for which contain main by C60 small and of C70. Fullerenes are the only pure form of carbon. They have smooth structure without dangling bonds. C60 molecule has a shape like soccer football. It contains 6-membered ring and a 5-membered ring. 6-membered ring is fused with 6 or 5-membered ring. 5-membered ring is only fused with 6-membered ring. All carbon atoms are equal and sp2 hybridized. Each carbon atom forms 3 sigma bond and 4th electron is free and delocalized in molecular orbit, which gave aromatic character to the molecule. Fullerene molecule has 60 vertices and contain single and double bond of carbon-carbon. Now, what are orthosilicates? Simplest silicates which contain discrete silicate tetrahedral unit, that is, they share no corner oxygen, as shown in this diagram. Pyrosilicates. Pyrosilicate, the two tetrahedral units are joined by sharing oxygen at one corner. In orthosilicate, no oxygen atom is shared, and in pyrosilicates, one oxygen atom is shared between two tetrahedral units, also known as sorosilicate or disilicate. What are p block elements? P block elements are those elements that belong to group 13 to 18 of periodic table, also known as representative element. These elements are characterized by the presence of their valence electron in p orbital. P block elements exhibit a wide range of properties, from being highly reactive metal to non-reactive gases. These are the p block elements, group 13 to 18. Give reaction reasons for the following. Silicates. Why silicates are water repellent? Silicates are water repellent due to their molecular structure, particularly the presence of polar alkyl group like methyl group at, at the end to the second oxygen backbone. These create a surface with low surface tension, preventing water from readily adhering. Boric acid is acidic. It is considered an acid because its molecule, when dissolved in water, accepts hydroxide ion from water, resulting in release of a proton. As it can accept pair of electron from hydroxide ion, it's an acid. Why fluorine is a p block element? Because fluorine valence electron occupy p orbital and its electronic configuration is 1s to 2s to 2p5, indicating it has 5 electrons in the outermost p orbital shell, and the p block elements are the elements in which the valence shell moves to the p block. Why triethylamine is less basic than trimethylamine? This is due to the silicon atom in triethylamine, which is vacant d orbital. These can participate in pi-pi backbonding with nitrogen lone pair, delocalizing the electron density and reducing availability of lone pair for protonation. Silicon is less electronegative than carbon. Triethylamine are less polar than trimethylamine. Nitrogen atom in triethylamine is less able to donate its lone pair electron. That's why it's less basic. And these are few more reasons like inductive effect, steric effects for the less basicity. Why phosphorus acid is a reducing in nature? Phosphoric acid is a reducing agent due to presence of one phosphorus hydrogen bond in its structure. Phosphorus hydrogen bond allows phosphorus atom to be further oxidized. Phosphorus atom has oxidation state of +3, less than its maximum oxidation state +5, which makes it capable of gaining electrons, reducing other substances. What is inert pair effect? Inert pair effect phenomena observed in heavier elements of periodic table, particularly in p block element, refers to the tendency of outermost s electron to remain non-bonding or to be less involved in bonding. What are causes of inert pair effect? The relativistic effect. As the atomic number increases, relativistic effect become significant. The inner electron experience increased mass, which can affect the energy level of the outer electrons. This can lead to a stabilization of s orbitals, making the s electrons less available for bonding. Poor overlap. The s orbitals are spherical while the p orbitals are lobular in shape. In heavier elements, the overlap between the s and p orbital is less effective, which can hinder the participation of s electrons in bonding. Effective nuclear charges. More protons are added to the nucleus. The effective nuclear charge felt by the outer electron increases. This can lead to a greater attraction between the nucleus and the s block elements, which can lead to the s block elements to remain non-bonded. Diagonal relationship between boron and silicon. It arises from their similar atomic radii and electronegativity, despite being in different group and period of periodic table. This similarity led to analogous chemical and physical properties. Both boron and silicon are known for their semiconductor properties. They can conduct electricity under certain conditions. Both form acidic oxides like boric acid and silicic acid. Both form volatile hydrides. Their hydrides are hydrolyzed in water. Both are considered non-metal with typical properties like high melting and boiling point. Explain the acidity order. So in the first one, the more positive oxidation state of chlorine, the more electronegative it becomes and draw electron density away from oxygen easily, making oxygen hydrogen bond polar and breaks easily, releasing H plus proton, thus increasing acidity. And in the next one, as iodine has larger atomic size, which makes Bi3 more electron efficient, and Lewis acid. This is the structure of diborane. As we can see that all the bonds are normal, but these but there is a 3 bond and 2 electron bond here. The structure of diborane molecule consists of 4 hydrogen atom and 2 boron atom coming on same plane. In between these plane are said to be 2 dividing atom of hydrogen. Boron atom is known to be sp3 hybridized and has 4 hybrid orbital. From these 4 hybrid orbital, 3 of orbital have 1 electron each, out of which one is an empty orbital. The 2 electron of the hybrid orbital in each of boron atom has 2 bond with 1s hydrogen atom. The 2 atom of boron left with that of each unpaired electron orbital and empty orbital form 2 bridging BHB bonds. There are 3 bonds, but the electrons are only 2, with that of 2 1s hydrogen atom, which are which is also called banana bond. Now the structure of borazine. The structure of borazine is isoelectronic to benzene, which we can say that its structure is same like benzene. Like benzene, borazine is a planar hexagonal structure, 6-membered ring. Boron and nitrogen atom are arranged alternately. Because of similarity between the structure of borazine is called inorganic benzene. They both in borazine, boron and nitrogen are sp3 hybridized. Each nitrogen atom has one lone pair of electron, while boron atom has an empty p orbital. Boron nitrogen bond is borazine is a dative bond which arises from the sideways overlap between the filled p orbital of nitrogen atom and empty p orbital of boron atom. Since borazine is isoelectronic with benzene, both compounds are aromatic electron cloud. Due to greater difference in electronegativity of boron and nitrogen, the electron cloud in borazine ring is partially delocalized, while in case of benzene ring, electron cloud is completely delocalized. What happens when borax is heated with aqueous H2SO4? Each react to form boric acid, sodium sulfate and water. As in this equation you can see the borax is reacted with H2SO4 in the presence of water molecule, and it gives sodium sulfate and boric acid. The boric acid can further react with ethyl alcohol to form triethyl borate. When boron trifluoride is heated with lithium hydride at 450 Kelvin, what happens? So a hydride of boron B2H6, specifically diborane, is formed along with lithium fluoride. When borax is heated with ethyl alcohol and concentrated H2SO4, what happens? A green edged flame is observed when the resulting vapors are ignited. This is because borax reacts with acid to form boric acid, which then react with ethyl alcohol to produce triethyl borate. The triethyl borate vapors, when burned, produce a green flame. Borax reacts with concentrated sulfuric acid to produce boric acid and other byproducts. The boric acid reacts with ethyl alcohol to form triethyl borate, which is an ester. This reaction is catalyzed by concentrated sulfuric acid. Triethyl borate form a volatile substance which produces a green flame when ignited. What happens when diborane reacts with excess of ammonia at high temperature? It produces borazine and hydrogen. This is the reaction. Reaction occurs at high temperature around 120 degrees Celsius. What is acid and base? According to Bronsted-Lowry concept, acid is regarded as a substance which gives off proton in solution. This proton is solvated, that is combined with one or more molecule of the solvent. In the aqueous solution, it combined with water molecule to form H3O positive ions, which are responsible for acidic character of acid. Here is example given. Base. Base is regarded as a molecule or ion which can accept proton given off by an acid. Thus, on the basis of this theory, acid is a proton donor and base is a proton acceptor. According to Lux flood concept, a substance which donates oxide ion is a base and an acid is a substance which accepts oxide ion. Base is an oxide ion donor and acid is an oxide ion acceptor. Substances which show tendency to give as well as take up oxide ion are known as amphoteric substances. According to Arrhenius concept, acid is any hydrogen containing compound which gives hydrogen ion in aqueous solution, and base is that hydroxy compound which gives hydroxyl ion in aqueous solution. Acidic character of an acid is due to the presence of H positive ion, and basic character are due to the presence of OH negative ions. In the neutralization process, H positive ion of acid combine with OH negative ion of the base to form water. Lewis concept. According to this concept, base is a substance which can donate lone pair of electron, and acid is a substance which can accept lone pair of electron. And the process of neutralization is simply the formation of coordinate bond between electron donor and electron acceptor. This is an example of Lewis acid base. Here NH3 has lone pair and BF3 doesn't. So BF3 accepts it and it acts as an acid and ammonia acts as base. Now, what are non-aqueous solvent? Any liquid solvent other than water, like liquid ammonia. These solvents are used in chemical reaction and processes where water could be unsuitable, such as non-aqueous titration. Aprotic solvents. Solvents that do not donate proton and cannot form hydrogen bond. Example benzene, carbon disulfide. They do not have hydrogen atom directly bonding to electronegative atom like oxygen or nitrogen, preventing them from donating proton. Ionizing solvent. Solvent that can undergo self-ionization or dissociate solutes into ions. Example water. It can ionize NaCl into Na positive and Cl negative. Non-ionizing solvent. Solvent that do not readily self-ionize and do not donate or accept protons. Example benzene. Non-ionizing solvents lack the ability to easily break down into ions through self-ionization. Protic solvents. Solvents that contain an acidic hydrogen atom, typically bonded to oxygen nitrogen, allowing them to donate proton and form hydrogen bond. Autoionization, also known as self-ionization, is the process where a molecule spontaneously splits into ion without need for external energy input. This means the molecule acts as both as an acid and as a base, resulting in formation of positively and negatively charged ions. Autoionization theory of solvent. This theory is based on the mode of self-ionization of solvent. Each solvent is considered to consist of an acidic part and a basic part, and on autoionization splits into these two parts, that is acidic part and basic part. A substance that produces or increases the concentration of acidic part of solvent behaves as an acid. Similarly, substance that increases the concentration of basic part of solvent behave as a base. The behavior of any solute is thus determined in terms of release of characteristic cation or anion of that solvent. For example, NH4 HCl is defined as an acid and NaNH2 as a base in liquid ammonia. So, when we add NH4Cl in liquid ammonia, it releases NH4 positive and Cl negative. So here the cationic properties are same, that thus it's a acid, and in NaNH2 the anionic property is same, that's why it's a base. Now HSAB principle, hard soft acid base principle. What is it? It states that hard acid prefer to interact with hard bases and soft acid prefer to interact with soft bases, leading to more stable complexes. This principle helps predict the stability and reactivity of chemical compounds and reactions, particularly in the context of Lewis acid base interaction. Hard Lewis acids are characterized by small ionic radii, high positive charge, strongly solvated, empty orbital in valence shell, and with high energy. Hard Lewis bases are characterized by small ionic radii, strong solvated, high electronegative, weak polarizability, and with high energy. Soft Lewis acids are characterized by large ionic radii, low positive charge, strongly solvated, empty orbitals. Acids and bases are classified as hard or soft based on their polarizability and charge density. Hard acids have high charge density and are not easily polarizable, while soft bases are more polarizable and have low charge density. Hard and soft interaction. HSAB principle suggests that hard acid forms stable complexes with hard bases and soft acid form stable complexes with strong bases. These interactions are often described as ionic for hard and covalent for soft. Application of HSAB principle, coordination chemistry. HSAB principle is used to predict the stability and structure of metal complexes. For example, it helps understand why certain ligands bind preferentially to certain metal ions. As the hard acid is added to hard base interacted with, and a weak base interacted with weak acid. Reaction mechanism. The HSAB principle can be used to predict selectivity reactivity of chemical reaction and the pathways involved. Biological system. HSAB principle has been applied to understand the binding of metal ion to proteins and the interaction of drugs with biological molecules. Solubility. The HSAB principle can be used to predict the solubility trends of different salt. What is symbiosis? The tendency of soft ligand to combine with metal ion already have soft ligand and vice versa is called symbiosis. Stability of complex increases if similar type group together. Mechanism of symbiosis. When a metal ion is already coordinated to hard or soft ligand, it becomes polarized toward accepting similar ligands because the electron cloud environment around the metal is adjusted accordingly. Hard ligand symbiosis. If a metal ion like aluminium is already bonded to oxygen donor like water or hydroxide, it will prefer to add more hard ligands. If a metal ion like mercury is already bonded to sulfur ligand, it will prefer to bond with another soft base. Now, what will happen when we add NH4Cl to ammonia? So it will give NH4 positive and NCl negative. So as we can see that the NH4Cl on dissociation give common cationic characteristic to that of the solvent. So NH4Cl is acidic in liquid ammonia. Now NH4Cl in water. The autoionization of water can be written as this. It gives H3O positive and OH negative, and NH4Cl when we add this to the water, it will give NH4 positive and Cl negative. So there are no common characteristic in cationic or anionic. Thus, we can say this is neutral. If we add NH4Cl to the ammonia, then the cationic properties no. SOCl2 is acidic in liquid SO2. So when we add SOCl2 in, it will give SO positive 2 and Cl negative, and the autoionization of SO2 gives SO positive 2 and SO3 negative 2. So as there is common cationic characteristic, that's why this is acidic. SOCl2 in water, this gives no common cationic or anionic properties, thus it is neutral. Now when we add NaNH2 in NH3, the autoionization of NH3 is this, and when we add NaNH2, it will break down as Na positive and NH2 positive. Common anionic character gives that this is basic in nature. Na2SO3. The autoionization of SO2 is this, and when Na2SO3 breaks, it gives Na positive and SO3 negative 2. Common anionic properties tells us that this is basic. Why solution of sodium in liquid ammonia is paramagnetic in nature, blue in color, good conductor, and are reducing in nature, blue color. When sodium dissolves in liquid ammonia, it forms a ammoniated electron, which absorbs red light and transmits blue light, giving the solution its characteristic blue color. Paramagnetism. The blue color is due to unpaired electron in the ammoniated electrons, making the solution paramagnetic. The presence of both ammoniated sodium cation and the ammoniated electron allows the solution to conduct electricity, reducing nature. Ammoniated electrons are highly reactive and readily reduce other substances. This combine with the high oxidation potential of alkali metal, making the solution a strong reducing agent. Thank you.